Hello friends, in this video I am going to discuss the application of first law of thermodynamics to flow process, that is devices which are steam nozzle and boiler. Nozzle is a device which increases the velocity or kinetic energy of the fluid at the exit of the nozzle, but is by at the expense of its pressure. So let us consider a nozzle. This is its control surface, and this is the wall of the nozzle, and the wall of the nozzle is insulated, so there is no heat interaction between the system and surrounding. Let us assume there is a mass flow rate of m kg per second across this control volume, and the general steady flow energy equation that is given by SFEE equal to H1 plus V1 square by 2 plus GZ1 plus dq divided by dm equal to H2 plus V2 square divided by 2 plus GZ1 plus dwx divided by dm. Since its walls are insulated, the dq divided by dm term becomes 0, and since there is no shaft in the nozzle, the dwx divided by dm is also 0, and neglecting potential energy changes, it is Z2, then the equation reduces to H1 plus V1 square divided by 2 equal to H2 plus V2 square divided by 2. Here H1 is enthalpy of the fluid at inlet, then V1 is velocity at inlet, H2 is enthalpy at exit, V2 is velocity at exit. Now the velocity at inlet V1 is very less compared to velocity at exit V2, so this term V1 squared by 2 can be neglected. So the equation reduces to H1 equal to H2 plus V2 square divided by 2. Then this can be written as V2 square divided by 2 equal to H1 minus H2. When this H2 is brought to left hand side, this becomes H1 minus H2. Now this expression can be simplified like this. It is V2 equal to, if you bring this V2 to right hand side, this will be 2 into H1 minus H2. So this V2 was previously V2 square. If we have to write V2 equal to this, then this will be square root of 2 into H1 minus H2. So this is the result of first law of thermodynamics applied to steam nozzle. Then let us apply first law of thermodynamics to this boiler. The boiler is a device in which steam is generated by receiving the heat that is produced by combustion of the fuel. This is the boiler in which there is a mass flow rate of m kg per second, which is at the liquid state at inlet, and it produces steam at the exit. That is also mass flow rate is m kg per second. Here steam is produced by receiving the Q amount of heat that is produced by combustion of the fuel. Then the general steady flow energy equation, SFEE, is H1 plus V1 square divided by 2 plus G into Z1 plus dq divided by dm equal to H2 plus V2 square divided by 2 plus GZ2 plus dWx divided by dm. See, in this boiler, definitely there is no shaft, so dWx divided by dm is 0. Neglecting kinetic and potential energy terms, this equation reduces to H1 equal to, H1 plus H1 plus this term dq divided by dm equal to H2, so this dq divided by dm, so dq divided by dm equal to H2 minus H1, so this can also be written as Q equal to m into H2 minus H1, as we write dq as Q and dm as m for the total heat transfer, then this will be Q equal to m into H2 minus H1. Here the increase in enthalpy from H1 to H2 that is equal to, it is heat supplied to the fluid, that is water, that is flowing inside the boiler tubes. So this is the result of first law of thermodynamics applied to a flowing process in case of boiler.